Number 8 is asking subtractive property of equality, or what is the subtractive property of equality? This is a pretty fancy word, but they give us the solution here gives us some type of definition. So maybe I'll go off that as well. But it's actually really easy when we explain it by when we're using numbers here. So it's saying, what is the subtractive property of equality? Well, this student from Waterloo says that subtraction property of equality tells us if we subtract something from one side of the equation, then we need to subtract the same side from the other side of the equation to balance the equation for both sides. So I like this. So I like this a lot because what they're saying here, for example, if I have x equals, I have some. Let me prove this first. Let me prove that this exists here. So for example, if I have some number a here minus some number b here, this will have to equal and equal some number c here. Or actually, let me do a plus b here. So a plus b equals c, and a and b and c are all real numbers. So they're all and maybe all integers actually, or all positive integers here. Don't worry if you don't know that notation, but I'm just saying that a plus b here equals c. For the property of the equality of work, what we need to do is if we want to subtract b here, if I want to get rid of b here, I need to subtract b to both sides, and that's what I'm proving here. Because if I have a plus b here, I'm going to subtract b on this side. So therefore, if I'm subtracting b on one side, I'm going to have to subtract b on the other side here, because minus b equals minus b, right? Again, I'm doing the same thing to both sides here. I'm adding. You can think of this. I'm adding minus b to one side, and I'm adding minus b to the other side here. And this guy here, you can think of b here, it's just a simple constant value, right? So if every time I take one subtraction from one side, I need to take to the subtraction of the other side here. This is a property of algebra that we use here to solve for equations, right? So given this rule, we can then say that a here is simply b minus b is obviously 0, so it cancels out. So c here would equal a here equals c minus b. So this here, and what we can do is we can prove this by subbing this back into our first equation here, and saying that a here, which is simply just c minus b, plus b here equals c. Negative b plus b, obviously they cancel out, so then c here equals c. So this here is a proof of the subtractive property of equality. If you didn't understand the letters here, I'm going to give you another example of this as well, and I'm going to use numbers instead, and they use numbers here. So I'm gonna copy this example and use numbers here. So they have x minus 3 here equals 10, and they're saying if we subtract 2 from the left side, then we get to this side here. So x minus 2, if we subtract here, let me say subtract 2 from ls. So when we say ls here, it's just the left side. So I'm gonna have x minus 3 minus 2 here equals 10. So x minus 3 minus 2 equals 7. I'm going to solve this equation now. So it gives us here, from this equation here, what we can say is that we could say here that we can move x here to the other side here. We get x here equals 13, right? So 10 plus 3 is 13. So knowing that from this equation x equals 13, I'm going to sub 13 here back into this equation here. So 13 minus 3 minus 2 here equals 10. 13 minus 3 is obviously 10. Minus 2 is 10. 10 minus 2 here equals 8 here equals 10. So that's no good, right? So this here is sad. I don't like this. 8 here equals 10 is not a very, it proves that algebra doesn't work here. However, if I subtracted 2 from this side, from the right side, so let's now say subtract 2 from right side, then now we get minus 2 here, I get minus 2 here, minus 2 here, then I can say that 10 minus 2 here equals 8 here, and this is now good, right? We like this stuff, right? 8 here equals 8 is a great equation here. It means our algebra works here. So therefore, what we're saying here, then we need to subtract 2 from the left side, and we need to subtract 2 from the right side. If we only subtract 2 from the left side or any other arbitrary number here, we're not going to get the correct solution. And algebra kind of falls apart here. So we need to do subtraction from both sides in order to keep our algebra consistent, to make us, again, 8 equals 8. It's a happy face, right? So we're good for that. So the solution here is correct. Good analysis.